Buenas tardes ya, bienvenidos a los que están en Internet. Seguimos en el taller de emprendimiento en biotecnología, estamos en la Biblioteca Benjamín de la Embajada de Estados Unidos y vamos a transmitir la plática de la doctora Matina Tsalavouta, perdón, que nos va a hablar sobre la comunicación de la ciencia en un centro de investigación público.
Thank you very much, Adriana. Thank you very much for the invitation as well. It has been a great 2 days for me being here. I have to apologize. I cannot deliver this talk in Spanish, but I hope I will speak slowly and clearly in English. As Adriana said, my name is Matina Tsalavouta, and I am the head of communications and public engagement at Rothamsted Research, and we are based in the UK. So what I'm going to do in the next, hopefully, 45 minutes, because I appreciate lunch is following, and it is quite important, so I don't want to keep you from that. I am going to give a brief introduction about Rothamsted Research, who we are, what we do, and our approach to communications and public engagement. And for that, I'm going to use 2 examples that relate to biotechnology. Although, as an organization, you will realize we work in a broad spectrum of agricultural science, not just traits that involve genetic modification. So, Rothamsted Research, we really pride ourselves in saying that we are the longest continuously operating agricultural research station in the world. We are providing cutting-edge science and innovation for 173 years. Rothamsted was established in 1843 by Sir John Bennett Laws, who also was an entrepreneur himself, and he discovered the superphosphates, the first fertilizers, inorganic fertilizers, which at the time they were not even using the word fertilizers when he commercialized his invention, and they were calling them Law's manures. So Rothamsted Research is the home of what are known now in agricultural science the classical experiments. So Laws, when he established Rothamsted, he was interested in crop nutrition and the effect that the combinations of organic and inorganic fertilizers may have in crop yields, but also in soils. So they established a series of experiments which have been continually running since 1843. And we have samples from each experimental plot, and here in the second, how can I just point this way maybe? Does it work? No. So, but here you can see a picture of one of the experiments. It's called the Broadbock experiment. It is very well known in agricultural science. It's a wheat experiment where there were strips of continuous wheat originally, and different combinations of organic and inorganic fertilizers were provided, and samples of the grain, the straw, and the soil were collected and stored. So now we have a collection of more than 300,000 samples originating from 1843 and for every year ever since, that we can go back and analyze. And we have records of the treatments that were received at the time, and obviously as time progressed, we started having weather data as well, so we can go back in time. At Rothamsted Research, there has been significant discoveries and contributions to science, and one of these has been in experimental statistics. So Fisher, who developed ANOVA and F-test and so on, he did his work, and part of his work, at Rothamsted Research, and he developed his methods, and also pyrethroids, so one of the very successful pesticides used were discovered in the 60s and early 70s at Rothamsted. So these are some examples of the contributions of Rothamsted to agricultural science. And the spectrum of research that I just mentioned, so soil science, agricultural statistics, bioinformatics nowadays, computational science, modeling, and so on, constitute nowadays still a big part of the research that we do. The same also for biological chemistry and crop protection. So, as I said, we are based in the UK. We operate in 4 sites in the UK, so all in the south. So the main site is in Harpenden, which is 25 minutes north of London by train. And we have a site in Devon, where we are doing grassland and livestock systems research, but also we have experimental farms nearby in Harpenden and also in the east of England. So there are approximately 300 research staff per year. We also have non-scientific support staff. We have PhD students, although we are not a university ourselves. So what we do is we have strategic collaborations with universities around the UK, and the students spend some time at Rothamsted and some time at the collaborative university, and they carry out the research. And we also have numerous visiting researchers from all over the world every year. So, because we have been operating for such a long time, we have long established collaborations nationally and internationally, and we currently work with more than 50 countries internationally. And our budget is approximately 25 to 30 million per year, and I will explain a little bit how we get our money. Primarily, we are a publicly funded research organization. We are an independent from government, though, research organization. So our legal status is a charity. Our purpose, our mission, is to do strategic integrated agricultural science that has impact in society, in agriculture, in the environment, positive impact, hopefully. So, and our products are really knowledge. So we do a lot of fundamental discovery stage work, innovations, and also people, developing careers, and supporting people development. So, as I said, what we do, our research spans, so if we have this kind of the pipeline, notional pipeline of research, our research starts at discovery stages, we move to proof of concept. We can also, through collaborations, do demonstrations, so multi-location trials and so on, but we don't commercialize ourselves. So we don't develop products in that way. This has to happen through collaboration with the private sector or otherwise, public-private partnerships and so on. So, and this is our funding, as I said. So we are one of 8 strategically funded institutes in the UK from the Biotechnology and Biological Sciences Research Council. So the Research Council receives the money from the UK government, a budget, to fund agricultural science and life sciences across the UK, so in universities as well and so on. However, there are also 8 institutes that they receive a certain proportion of money every year from BBSRC. So how do we get this money? We have every 5 years to develop our research strategy that has to fulfill the requirements also of the National Science Strategy. And for that, we have to bid. We have to convince the Council that we can deliver on what we hope to do. And for this, so far, we have been getting approximately 50% of our funding needs. The rest 50%, we have to raise it. And we raise it by applying for competitive research projects. most of it is we are bidding for the projects, again, to the BBSRC because of the remit of the research that we do. There are other research councils, such as the Medical Research Council or the Physical Sciences Research Council, but obviously our work wouldn't fit in that. And also we apply for competitive grants in the EU. We have industry collaboration in two types. So we have strategic alliance with companies such as Syngenta for a portfolio of research, but we also have for individual small projects collaboration with the industry because it facilitates the translation of the work and we learn. So the academic type of science with the more commercial environment. So we see it as a very beneficial way for us to work. So, and with regards to our impact, in 2015 we thought, okay, so we have been operating for so long, we know we have made significant contributions, could we put a value to this? Obviously there are certain caveats in economic analysis over so long period of times and so on, but we did commission an economic analysis of this nature, and the conclusion was that approximately the research that Rothamsted has been doing and the innovations that it has delivered over the period of operation contributes an amount of approximately £3 billion a year. This was derived by taking into account how much the food would cost in the UK, food and drink, so the whole sector, if agriculture was operating in a different way without the contributions of Rothamsted. So, and now moving forward, as I said, every 5 years we have to develop our research strategy in order to get our strategic funding from the BBSRC. And we are in this period now, in the transition period. So our current program ran from 2012 until the 31st of March of 2017. So we have been developing our new strategy moving forward. And we have 5 large strategic programs that we are hoping we will secure our funding from the BBSRC for the next 5 years. And these are the following. So the first one is focusing around wheat. We call it Future Wheat. It is a really big national program covering all aspects of wheat research. And we are a big partner of this national project. We are focusing on soil nutrition, so we're looking across the whole system and cycling of nutrients, both for grassland and arable systems. We are looking into sustainable intensification, smart crop protection, and tailoring plant metabolism. So this is where some of our work also with biotechnology is falling under. So, and all this, so the research, this is where we will receive our strategic funding for, and then we will also raise further funds for projects around these big strategic themes. And for us, in order to operate, we consider it really important and to deliver impact through this research, to have a very structured knowledge exchange and commercialization strategy, a communications and public engagement strategy, and work with agri-tech centers in the UK, as well as establish strategic partnerships nationally and internationally. So this is the way that we are organized moving forward, still remaining an independent research organization. So, how do we approach, so how do we put this in practice, and how do we approach innovation in the next 5 years? So we have our integrated research programs that I mentioned. Obviously there were 5 stuck along, but there is a lot of interaction across. And we have an internal mechanism, which we call the Rothamsted Research Innovation Pod, where we offer training and support for all the researchers to develop business skills, to learn a lot, similar to the discussions that you had today. And for this, we work also with other organizations that they come in and they bring their expertise. So the Innovation Pod is really an internal mechanism to support our researchers and identify provide the skills that the people need in order to develop their innovations, but also to identify projects that they can move perhaps faster towards the market potentially. And then we have this third element, the agricultural research innovation accelerator, which is here we bring our external partnerships, investors, seed funds, university collaborations, and we try to adopt a kind of a lean science approach there. So maybe some projects that they are higher risk and you can move them faster, test them faster. If they work, you move forward. If not, you stop and you move on. So it's a bit of more high risk, but potentially could deliver a different type of innovation than the kind of mainstream agricultural science that we do. So, and for this, we not only have the concept, the business model for this, as I explained, but we also have the physical space. So our laboratories are in our facilities. We have the main research buildings where we have always been based, but recently we developed an open innovation hub, so that is physically linked to our laboratories. And there we try to attract also companies to move on site for perhaps short projects that they have, and they want to access some of the facilities that we have, like glass houses and big experimental equipment and so on. We have incubation facilities. So once the companies move from the one stage, they can move into the incubator space potentially. We have conferencing facilities and so on. And so, and this is how it looks. So here is all the buildings, and we have also 330 hectares of experimental farm. This is in one site alone. So we can move the experiments from the lab to the glass houses to the farm in one space. So this is really what Rothamsted is and what we do in a nutshell. And if I have gone fast, please ask me later. And so, as I mentioned previously, for us, communications and public engagement is really important. It's really important in order to deliver ultimately impact to society and to the farming community in the UK and internationally. And the earlier we engage in the process of listening to what the people need, to what the people think about innovations, the better it is for the innovation itself. So people may be positively affected, or some people may think they may be negatively affected. So if we listen to them early on, is there something that we can do in our research phase or in the development phase to address potentially through the product the concerns that people have? So we take a very proactive and strategic approach to communications. And so here is just to demonstrate that for our science strategy in 2012, we also developed a communications and public engagement strategy. And we have 4 core principles in our communications and public engagement approach, which is to be really proactive. So we go out to tell people what we do. We have this responsibility. We are primarily publicly funded. We ought to tell people what we do, but it is important for us also to listen. To listen. What do people need and what do people think? We have to be always accurate and clear in what we are saying. We have to be transparent, and we have to earn credibility. Credibility is earned. So we have to earn that by our approach, and we have to encourage and support public dialogue in what we do. So, now I'm going to explain 2 examples relating to genetic modification that will hopefully demonstrate how we put into practice these principles and how we approach communications. So, in 2011, colleagues of mine at Rothamsted had been working on chemical ecology and trying to understand the interactions of plants and pathogens. They had discovered some pheromones that aphids release when they are attacked, and these repel the enemies of the aphids. So they thought, what if we put these pheromones into wheat plants, and then the plant itself could release these pheromones to repel the aphids, and therefore there would be less need for pesticides, because people have to manage the aphids because they damage the yields. So they put a competitive project proposal with this hypothesis to the Biotechnology and Biological Sciences Research Council, and the proposal was funded. So they started developing the plants in the laboratory, and so they had identified the genes, and they transformed the wheat, and they developed the plants, and they tested them in the laboratory, and they found that the results were quite promising, so in the lab. So the next step would be, can we test these plants in the field? So the hypothesis was the wheat will emit this pheromone, and it will potentially repel the aphids and also maybe attract some beneficials that feed on the aphids. So we put an application together, and that was in the, for getting a permission to do a trial, and obviously we made a public announcement. And people, when they hear about GM crops, so in the UK we don't grow GM crops commercially. There's no GM crop grown at the moment commercially. So not wheat, nothing. But people are interested. It's a controversial topic, and because we only have experiments that potentially we can grow GM crops, we engage in conversation. So people have they come from different perspectives into the debate. They have their values. They believe, you mentioned a lot, and you discussed about maize here in Mexico, about interfering with life, and so on. A lot of this is value-based, and it is very legitimate. Every person is entitled to their view and their opinion, and their belief, and their approach, and the way that they see the world. So we need to listen to them in order to engage in conversation. So people have concerns about who is benefiting with this new development, who will actually earn money or have a benefit, a social benefit, or better nutrition, or better health, or an environmental benefit. People are really concerned about this. Some people have fears of the unintended consequences, or they have concerns about the environmental impact of the intended use of the new trait. And some people are unsure. They don't have an opinion. They don't know. They are not particularly engaged in the debate, but they hear about it, and that generates interest. And what we also want is to have a science and evidence-based, well-informed discussion and debate. And for this to happen, one is obviously to provide the information accurately and clear, but to start from a point that to acknowledge and recognize that they are all valid points for each individual that has this, it doesn't, yeah, like this, that has these concerns. So, and we listened. People gathered together to protest in our field station. This is where the site in our farm was. So that was the experimental design for the wheat trial. The little plots here is where there were experimental wheat plots grown. 4 of them had the genetically modified plot plants, and the other ones were controls, and in between there was barley as a buffer, and then there was also a zone around it with wheat, non-GM wheat, so that we could control. We explained where the trial will take place. We said when we will do the sowing, all the information was in the public domain. And when people said, okay, we will come and protest and we don't want you to do your trial, we said, okay, let's discuss. We invited them in dialogue. That we had an intrusion, so someone intruded one evening to try and destroy the trial, but they didn't. And we continued our efforts to invite people in discussion. So when we sent a letter and asking the protesters to come and join us in a conversation, they didn't engage. They didn't want to come to have this discussion. And they continued threatening that potentially they would destroy our trial. So my colleagues, we made a video where they made a plea and they were saying, don't destroy research. We are doing an experiment. We would like to know, and we will let you know if it works or not, but we would like to see our experiment in the field, because this is how science works. If it was any other crop, we would do the experiment in the farm. And so we did that, and people responded to this. There was a petition. There were more than 4,500 people that signed a petition to say not to destroy the trial. And we hosted visits. So members of the public, the interested groups and so on, they were coming on site almost on a daily basis in the first couple of years to see the experiment, to meet the scientists, to see what Rothamsted does, and to explain. It was intensive. The effort was very intensive. The engagement, it takes a lot of work, but it is really important to do. Eventually, the trial was not destroyed. The experiment went ahead, and it was concluded. And keeping to our promise, when we finished with the analysis last summer, we published the results. And the results were that the wheat in the field did not repel the aphids. So that was an example of a GM crop to be developed, to be tested, that did not work. And we told everyone, as we promised that we would do. So it was covered in the BBC, it was in all the newspapers. Again, we had people interested in the work, and that generated a lot of conversation amongst in the public domain. So here, for instance, is an example that shows that in the same newspaper, there were two different articles written. And we disclosed, when we published the results, we also disclosed the cost of the security. Because of the threat, we had to increase the security on site. So the experiment, the 5-year research project, including the laboratory work, cost £750,000, UK sterling, and the security was 2.2 million over 2 experimental seasons. Because we had to put fences, so there was some infrastructure, we had to put cameras, and also there was manned security. So we disclosed that when we released the results. And people were saying, some people were saying, oh, £3 million, public money wasted, the experiment didn't work. But some other people were saying that anti-GM protesters don't understand how science works. James? Is that okay? Yeah. So, and it was an interesting conundrum to try and explain and say that although the experiment worked because we had the controls, the experiment was concluded, it did not repel the aphids. So it was not a waste. So we learned from this, and then in 2014, before we had published our results for the GM wheat trial, we had a new different experiment that we wanted to do, and it involved again genetic modification. So, and this is a completely different topic, and here is the sea, not very relevant straight away to agriculture, but so what is the experimental question now here? So, the omega-3 long-chain polyunsaturated fatty acids are beneficial for us and are essential for fish to grow. Fish in their natural environment, in the sea, they get the polyunsaturated fatty acids through their feed. Although we call them fish oils, in short, the omega-3 fish oils, the fish do not make them in their organism. They only get them through their feed. So, currently, we have more fish produced from aquaculture than captured in the oceans. And these fish in aquaculture, in order to grow, they need supply of omega-3 fish oils. So we have to harvest these fish oils from the oceans and provide them to the fish feed in aquaculture in order for us then to feed on the fish and get the omega-3 fish oils. So, but they are a limited resource. They limit the rate of development of aquaculture, and obviously there is a strain in the sustainability of the environment. So my colleagues thought, what if we make a crop, an oilseed crop, that can produce these omega-3 long-chain polyunsaturated fatty acids, the natural producers of which are algae. So most plants produce omega-3 fatty acids, but not the long-chain polyunsaturated fatty acids. So, and what they did 20 years ago, they started working with algae. They identified the genes that are required to make omega-3 long-chain polyunsaturated fatty acids. And finally, they modified a plant, which is called a camelina, and it is distant relative to oilseed rape, with 7 genes. They changed the whole metabolic pathway of the plant in the seed specifically, in order to produce these omega-3 long-chain polyunsaturated fatty acids. And after all these years of work, in 2014, they demonstrated with plants in the glasshouse that they can develop plants. So at the top there is the bulk fish oil that is being given as a feed to the aquaculture grown fish. And the 2 yellow pieces of the pie, I'm sorry, the resolution is not very high here, are the long-chain EPA and DHA. And here is the genetically modified plant that normally does not have any EPA or DHA, and now we have modified it to make in sufficient amounts and sufficient proportion EPA and DHA. Obviously, that was with plants grown in the laboratory, and the next step was to test whether we can, under environmental conditions, have plants that deliver similar quantities and amounts of omega-3 fish oils. And we applied again for a GM trial. We made it public, the fact that we apply for, we want permission to do. We invited everyone that had interest in this, before even we got permission to do the experiment, to come and talk to us so that we could explain to them the science and what we are doing. This is a different crop as well from wheat. Obviously, it can attract bees. It has light pollen that can travel, different ecology. And environmental risk assessment. We had public meetings and so on. And we got permission. People didn't demonstrate. They didn't oppose. We listened to what people told us. And some people had concerns. And some of the concerns were regarding honey, because we have honey production in the area around Rothamsted. So although it was not a condition of the risk assessment to put a net around on top of the crop, the GM crop, when it was growing. We said, okay, we will put a net, but not only this. We also, because we do have bee science and biology, and we have our own honey production as well within Rothamsted, we set up an experiment with beehives. So we set beehives in different distance around the farm from the experiment, and we then analyzed the samples to see whether we could trace pollen. In this case, it would have been white type, most likely, from the barrier, the pollen barrier. And we also make this information available. That was an additional experiment. It was not part of our regular business, but it was an additional experiment that we set up in order to address the concerns that people had and to be able to evaluate, how far does this pollen travel? Does it, are the bees attracted and they go? The national media, they were very much interested in this experiment, and they requested to film the whole process. So from when we do the sowing to when the crop reached flowering, and also when we did the harvest. So it was a few months that we were working with the media, and they were there monitoring. And again, when we gathered our data and the information, we published the results, always in open access, the publications, but also we tell the media, we tell the people, and that was again last summer. Soon after, we had published our results about the GM experiment that had not worked. So, and this one showed that, okay, the UK trial shows that fish oil could be grown in the fields. So, have we, in close to summarizing now and finishing, how did we address the concerns and the issues that people have? So, and one of that is, okay, what about the environmental risks? And obviously, this is at experimental scale. As I said, we don't grow commercially in the UK, but even at that scale, people are very concerned. And also, the system in the UK and the authorities is very open and rigorous and gives the opportunity to people to check every single aspect of the process of growing a GM crop. So when we make an application to get permission, not when we have the permission, when we get an application in, we have to put it in the national newspapers. We provide a 6-digit grid number. Everybody knows where that experiment will be. In our case, it is very good that everybody knows, because very close to the GM experiments at Rothamsted, we have some of our classical experiments that I mentioned before. If somebody wants to come and trust the experiment, it's better that they know, where the experiment is. But it's also important from a regulation point of view. So the approach of the UK government is the moment that someone applies for a GM trial, that information is publicly available. The risk assessment that we had to submit, and it had to be evaluated by an independent authority, is available. All the information is available, unless there is commercial confidentiality, obviously, for some aspects, not the full details. There is very rigorous and thorough also monitoring from independent authorities, and they come and they assess whether we comply with the conditions of doing an experiment, and all the reporting is again in the public domain that everybody can access. When people have concern of who is benefiting, well, ultimately it is the UK taxpayer that will benefit. Even if it has this crop, the omega-3 fish oils crop, if it has to be commercialized, and we have IP, obviously, to protect the invention and so on, and if we work with a company to commercialize it, because it won't be us doing it, and then there are some returns at Rothamsted, and Rothamsted can continue doing science for longer, the knowledge, the innovation, the UK being a leader in the field, is for the benefit of the UK taxpayer. Do they recognize that? Well, we asked them. So we discussed, we did a formal public consultation and public dialogue of the underlying principles for Rothamsted working with industry. What is the non-permissive elements? Because ultimately the UK taxpayer is our main funder. So they have a say in how we should work and operate. So we did almost a year consultation with members of the public, where we had facilitated dialogue events, and we co-developed the principles that should underpin our intellectual property strategy at Rothamsted and the approach that we should have in working with industry. Because we know, moving forward, the public funds get less and less, and we have to work more and more with industry to deliver the innovation, because it's not our remit to do so. So, and that was a very interesting exercise, because most of the members of the public that participated, they appreciated that, yes, we have to work with industry, that it is not, some people are concerned, and they think maybe working with industry is a negative thing, you may be biased and so on, but it's not the case. And why Rothamsted is attractive to industry and work with us is because we are independent. And we can do work because we work with multiple partners. Obviously, if we had only one collaboration with one company, getting 30% of our funding by company X, we would be almost company X. But it's not the case in our case. So in conclusion, so the summary of the two trials that exemplify our approach, and as I said, the overall approach to communications is for the whole spectrum of research that we do. But these GM trials are more relevant to the discussion here and exemplify more. So with the GM trial, we had protests, we had threat, we have to have high security, we had extensive engagement and communication. The experiment was concluded and we published our results. With the GM Camelina field trial, the omega-3 fish oils project, the experiment is ongoing. At every stage of the experiment, when we have data, we publish. We didn't have any protest. We didn't have any threat. We have reduced the security completely, almost to the physical security that is on site. Again, we engaged, and in that case, we engaged much earlier even in the process. And we have had successful conclusion of 2 field trials, and by the time I go back, the 3rd will be finished. So, and with that, I would like to thank you, and any questions, and obviously my colleagues. We work all together. Every scientist involved in every project takes a very proactive approach to communication and public engagement. So, thank you very much.
Thank you very much to Matina. If you have questions, you can do it in English or in Spanish.
Well, thank you. Thank you for your presentation. It was nice, amazing. So, 2 questions. How
Sure.
can I work with you? And second, when you make some research, what do you think is the first trouble in your public agenda in UK, and try to solve these troubles with your with this organization?
Yeah, so we don't start from a point of view that there is trouble, controversy, or concern. Our motivation, irrespective of what the subject is that we have to inform people on what we do. We have to listen if they have views, because, okay, so the GM is controversial, but we do research on soil science, that it could have environmental aspects that they're not major controversially, but for some people they could be interesting. So the motivation is really to engage with the stakeholders, with the actors, and to listen. Now, obviously, for some of the work, we know that they are more controversial than others. And there it is imperative that we tell everyone early on. So sometimes if you think about innovation, there might be things that we cannot predict early on in the science, that they may be controversial. So the earlier we engage and we speak about this research, the potential implications as we understand them now, whether they will be, what will be the uses, who will be the beneficiaries, who will have access to this. Maybe we identify issues that people haven't, we haven't thought. That's why it's important to listen. And maybe we can do something about it also with the remit. So yeah, it is obviously knowing what is the landscape, but also engaging, because by talking and listening to people, you also learn. Because there may be those that we think they will be positively affected, but we have to consider that there may be some that obviously the innovation does not intend to negatively affect, but they may be affected, so we need to listen.
Thank you very much for your presentation. I would like to... Me gustaría hacer la pregunta en español.
Sí.
Primero, muchas felicidades por incluir a la sociedad. Es algo muy importante, muy interesante, que ojalá que también se haga aquí en México. Segundo, ¿tienen programas de becas para alumnos o intercambios de aquí a alumnos mexicanos? Y tercero, si tienen alguna línea de investigación en bioremediación.
Okay, so the second question relates, I think, to one question that I haven't answered yet about the collaboration, right? The first one was the point about including the society and working together, and that this is really important. That was the point. Was there a question on this? Thank you very much. I think it is really important, and it is a way moving forward to be inclusive and to listen, and especially for an organization like us, where we're getting publicly funded, we need to engage the interested parties in this. And the more we engage, I think, the better the innovation, the product of the innovation ultimately will be. Because it will reach the people, because they will have contributed along the way to the development of this. There's no point for us sitting in our nice facilities at Rothamsted for 30 years developing something that in the end no one wants to use. The industry will not develop and there will be no market for it. So there's no point. So no, not directly. So. Yeah.
I have first congratulations for your presentation. It's incredible, amazing what you are doing in UK, where your company, BBS and RC also. My question is all these projects, you are spending a lot of money, right? With projects that you don't have the certainty that you're going to have or be success, right? And it's something that maybe we have to learn in Mexico also. But the question is all these projects, including the failures and the success, are under or attached to a national plan of sustainability in UK, right? Because normally innovation is just an idea, and in Mexico we are following always, this is the best ever idea that we're going to solve something. But we are not taking into account if the country or nation really needs that solution, right? So something that we have to learn also is that our ideas has to be attached or engaged with the national sustainability plans of our own country, because if not, the money never going to come, right?
Yes. So Rothamsted, and this is one thing that kind of makes the difference between Rothamsted and other and universities, not other, and universities, because we are not a university, is that that's why we say we are a strategically funded institute. So we have long-term funding. The 50% that I explained, it comes from indirectly from the UK government in order to support themes of research that they are of strategic priority for the UK. And so I mentioned the wheat project or the sustainable intensification of agriculture and so on. Although there are 5-year cycles in funding, and every 5 years we have to really prove ourselves, of course, we have been working for the last 15, 20 years. It is how you move that forward. It is a long-term investment by the UK government in that crop. And understanding a lot, understanding nutrition, crop architecture, agronomy, biology, developmental stages, everything, interaction with the environment. So there is a strategic approach, and the Institute, by its legal status, it has to follow a strategic approach to research. Now, there are some projects that they are more like in a university that, you know, there is very nice, interesting research, a fundamental question, blue skies, and so on. And we do some of it, but the primary work that we do has to be strategic research. And then people are in universities and they explore this because we do need the exploratory science as well. A lot of the major things that are around us today have their foundations in this kind of blue sky research. It is just long term, maybe, you know, too long term. So,
okay, thank you. From the internet, we have also many congratulations to you. And there is a question just asking if the research is only done on open fields or also on greenhouses.
Yes. So the research is being done also in greenhouses. So we have laboratory space. We have a few thousand square meters of laboratories. So that's the primary buildings that we have. And we have, I think, 42,000 square meter of glass house space. And there we do a lot of different types of experiments. And then we have the 330 hectares of farm on the Harpenden site, and then we have also other experimental farms. So altogether, our farms are more than 700 hectares that we do experiments. But, so we do many experiments that in their normal breeding. We are working on willows. They have nothing to do with genetic modification. And to put it into perspective, so the two experiments that I mentioned here, you saw the fenced area. So this area is in our main campus, in our Harpenden site. The whole farm there is 330 hectares. The fenced area is 3.2 hectares. And within that fenced area, the experiment is 100 by 100 meters. So it is less than 1% the experiments for genetic modification than we do in the field. The rest of the experiments in our farm are other type of agricultural science. But because it is an interesting topic, it attracts a lot of attention. But it really is not the primary. We use, for traits that we need to develop, we will use biotechnology. That's fine. But obviously there are a lot of other tools and approaches that we need to have and we need to do research on. So, and we do that. We do agroecology. We have a whole department of agroecology at Rothamsted that we are looking at beneficiaries, field margins, interactions, and so on. So at the farm scale. So how you can increase biodiversity at the farm and so on. So we do all this research. So.
Gracias a los que nos están escuchando en internet y vamos a continuar con las preguntas ya aquí en el salón.
Thank you very much.
Hi. Also, congratulations.